What's up, everyone? Welcome back. Patrick here. Moving on to the next thinking problem in the exponential functions unit test. So here we're told that a car depreciates in value at 18% per year. How many years does it take to depreciate to 40% of its initial value? So I wanted to do a couple of questions like this where notice in this particular case, we are not given the dollar amount of the car, the initial dollar amount, but we actually don't need it. So just in general, this kind of question is set up like this, right? And then x here, x is gonna be the number of years. So we got the final amount of the car is gonna be the initial amount, 1 plus r. Now remember that if this is a growth question, r is gonna be positive. If it's a decaying question like this one is, because it's saying the car depreciates 18% per year, this r is going to be negative. So we know that in this case, r is going to be negative 0.18, right? You always take the percentages and convert it to decimals. This r always has to be the decimal value. Okay, but notice we're not given the initial dollar amount. And what they're asking us is how long is it going to take for the car to depreciate to 40% of its initial value? So let's first set up the equation with the r. So I'm going to bring in the r here. This would be 0.18 like this. This is going to be to the power of x. And then notice that this bracket here, that's going to simplify to 0.82 to the power of x. But notice, how are we going to solve for this x if there's all these other variables floating around, right? We don't have a dollar amount to plug in for this I. Well, we are told that the final amount is going to be 40% of the initial amount. So we could plug in 0.4 I for the final amount. Then we're going to have I here, and it's going to be 0.82 right here to the power of x, like that. So it actually doesn't matter what that initial amount is, because what's going to happen is we're going to divide both sides by I. The i's are going to cancel out, and we're going to be left with 0.4 on that left side. So for example, let's say that our initial amount was 500, like that, right? And we had 0.82 to the power of x. Well, what's 40% of 500? It's 200. So if we plugged in 200 here, right? So if we were to solve for x now, when we divide both sides by 500, notice 200 divided by 500, it would end up being 0.4. So it doesn't matter what that initial amount is. All that matters is the proportions. Okay, and I mentioned this in previous videos that you don't necessarily need to be given an initial amount if you're given the rate and if you're given the final amount as a percentage of the initial amount. And you got to read these carefully. Now, in this one, they said it's going to be 40% of the initial value, but they could have also said that it depreciates by 40%. Okay, so how long is it going to take for the car to depreciate by 40%? Well, then you would have to plug in 0.6 I for the final amount, right? So you got to read these super carefully, but in this case, they said specifically how long is it going to take for the car to depreciate to 40% of its initial value, right? So here we're going to plug in 0.4 I. And so from here, what we do, divide both sides by I. Notice that these will cancel out, cancel, and we would be left with 0.4 equals 0.82 to the power of x, like that. And then remember, if you're trying to solve for this x value, the formula that we use, if we got n equals m to the power of x, and we're trying to isolate for x, x is basically going to be log n divided by log of n, like that. So here, applying that, x would basically be log of 0.4 divided by log of 0.82. And that's going to be 4.6, like that. Right? So it's going to take 4.6 years for the car to depreciate to 40% of its initial value. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.